So the thing about electrical engineering is there's so many different roles, they can all interlink and all combine. And in this video, I'll try and break down what exactly those roles are and how you can implement them into becoming whatever you want to be, whether that may be academically, professionally, or even just in your hobbies. So let's get started. So first off, you've got an electrician. An electrician is just kind of like the regular one you hear of when you think of an electrical engineer. They are essentially the tradesmen behind the craft. They can wire up electrical circuits and wire up your lights, wire up your cookers, all this to a central fuse box within your house. This is probably the most useful type of engineer, electrical engineer, to somebody who isn't in an electrical engineering field. And this is probably why it's the most popular and most well known. Another one we can look at is a power engineer. Power engineer is basically someone who works on the power grid. This is essentially your outside power poles and power pylons, which are transferring energy between thousands of homes and transferring energy between different locations that might need it, such as dockyards, shipyards. Everything that might need high voltage power comes from the power engineers who can create, generate, and then supply to the rest of the world. Now let's look a wee bit into control engineering. Control engineering can come from both an electrical side and a mechanical side. It's basically where you take an incoming electrical signal and manage it so it works well with your devices and works well with your systems. This includes creating sort of feedback loops like PID devices, which essentially take a signal, read from the output what's happening, and feedback back into the income signal to make sure you're getting that same consistent signal as you're going along. This is essentially the efforts to keep the input signal the same or similar throughout the entire system's life process. This means if there's a surge in energy or a lightning strike or something like that, it can stabilize back to what it's supposed to be, as opposed to having crazy signals and then having an odd signal which totally sets off your system. The control engineers are basically trying to route signal from the power engineers into more electronic components and different parts around whatever it may be or around a specific project. So instrumentation engineering basically just comes straight off the control guys, because the control guys have provided an incoming signal from which the instrumentation guys can then use a smaller signal, such as a 24 volt supply, to then go and supply their devices. The instrumentation side of it is more on the actual devices themselves. So say for example you're wanting to power a motor, the instrumentation guys will deal with everything to do with the motor. What motor they're choosing, how is it connected, how much power is going to it. The power will be defined by the instrumentation guys, but set up by the control guys. Now, taking a step even further down than instrumentation, there is electronics workers. And electronics workers are essentially building the instrumentation devices. So, stay with me now. The instrumentation devices can be connected and implemented into systems in certain ways, but that is all designed from the electronics guys. So essentially, these are people that build devices and create data sheets behind these devices to show how they work, how their PCBs work, how all their electrical incomes and outcoming signals are processed, their formulae behind their kit, whatever it may be. These are the guys that make the kit themselves and then manufacture it and send it off to everyone else. Simply put, the instrumentation guys need the electronics guys because the electronics guys are making the vital kit which makes the whole system work. And if the instrumentation guys can implement what the electronics guys have made, then you can then pass it on to the control and the power, and long before you know it, you've got a whole system ready to go. The instrumentation guys can combine many different components from different companies, different makers of these electronics devices into one big system, and that will again feed back down from the control guys, which have sent them whatever signal they may need. Another type of engineer is a signals engineer. This is somebody who can take and interpret signals and see how they can change them, how they can manipulate them. For such things as noise cancellation, for image processing, for radio frequencies, these are all dealt with by signal engineers. So essentially what they're doing is understanding signals, manipulating signals to create something else. Similar to a signals engineer, you can get a telecoms engineer. A telecoms engineer is basically somebody who works on telecommunications, which is your phone signals, your internet signals, all these power poles which can create a network of wireless interconnectivity between millions and thousands of people. These are all done by your telecoms engineers. Again, this kind of starts from the apprenticeship level. You can get in with a big company like Sky and become a telecoms engineer. The telecoms engineer may fix and maintain the poles, or they may go to the next step up, which would be designing the poles and picking locations and essentially improving the Wi-Fi and telecommunications among the entire world. So think about like stuff like Starlink, which is essentially internet wherever you are. Another section is microelectronics. Microelectronics basically provides all the chips you may need for all your common household needs. They may provide chips for PCBs, which can then be integrated into larger devices and machinery. There is a whole industry behind manufacturing and designing these tiny chips, and there's multiple ways you can get inside it. You can get in through the apprenticeship, become a warehouse person for a silicon chip manufacturer, or you can go down the degree route and become a chip designer. And then that leads us on to nano electronics. So nano electronics are like microelectronics, or even smaller. So one very known law is Moore's law, which essentially means every year the number of transistors on a chip halves. And this is the work of nanoelectronics. You're working on tiny little transistors, which there are probably billions of them in your phone at this point. And each little transistor is simply a one or a zero, an on-off switch. That's all they essentially are. But they create amazing things such as a phone, your computer, your laptop, anything along those lines, are all created by tiny little transistors. And it's amazing how many more of these are getting created, because it's one of those things that are a phenomenon. We're getting to the point where we need to use quantum computing, which is an even more complicated subject on how to actually get a state between 1 and 0, because we're getting so incredibly small, it's almost hard to fathom. But this is the work of nanoelectronics. So getting on to one of the fun ones is embedded circuits. Embedded circuits are essentially the brain and the power behind specific tasks and specific things around your house. Think about your microwave, for example. That knows the time at all times, but also has more functions, which are powering your device and working your device with an LCD screen. These are all parts of embedded functions, which is essentially the bit behind what the user sees. So what you wouldn't usually see is what you're creating as an embedded engineer. As an embedded engineer, you're basically trying to find new clever ways to work your way around the user. So the user should have no idea you exist, and probably don't even want to know you exist, let's be real. Another field that often gets missed is digital electronics. Digital electronics is creating devices with logic gates and very low level code to essentially operate very fast, very efficiently, and essentially closed circuit, which means offline in its own system, not connecting to anything else. And it's especially useful in standalone devices. Think about an ATM, for example. It needs to work on its own device. So you might use an FPGA, which is a digital program, essentially, to create the ATM, as opposed to using something that can be hacked or something that can be externally accessed. And then probably the most fun one for last, robotics and mechatronics. It's essentially designing robots that create different things in manufacturing, they create different things in retail, and they're essentially robots that work towards achieving what you could do as a person. So, for example, in car manufacturing, robots are used to weld doors and create every car exactly the same. And you could have a maintenance kind of role with this. So you basically fixes the machines as they break down and make sure you perform reactive and proactive maintenance on large-scale industrial machines. Or you could go into the more design side of things, where you're designing mechatronic machines for these warehouses and to last for a good amount of time for whatever your company may be, whether that's Tesla, whether that's Volkswagen. You're creating large-scale machinery to then create essentially more machines. And a wee nod off to robotics is great for hobby crafting. You can create as much as you want through firstly Arduino, then you go into 3D printing, you go into PCB printing itself, and once you kind of get the grasps of how to create a brain, you can essentially make whatever you want to make. The main aspect you should take away from this is all these fields do overlap, and you will likely have to dip in a wee bit to each and every field. No matter what kind of a field you're in, or no matter what kind of industry you're in, you're going to have to dip in a wee bit to the other ones as well, which is part of being an engineer, which keeps you always learning, always going forward. And it gives you more opportunities to grow, because if you can dip into each field, you may want to then go and specify that field if you really like the field that you've dipped into a wee bit. But I hope that helped you out in order to try and figure out what's actually going on in electrical engineering and give you some sort of guidance behind where you could go, what you could do, and that was essentially the goal. But yeah, I'm Jordan. If you need any career advice, please be sure to check out my website. And if you want any more from me, give me a comment, because I don't get too many of them, so I try to reply to every single comment. And other than that, I'll see you in the next one. Take care.